So now, here we have a PNP bipolar junction transistor 2N3906 wired as an emitter follower. So the emitter there comes up to that jumper where we're measuring the voltage. Now we got the trim pot voltage. I bumped things so it kind of changed. But in case it's at 5 volts. Now I'm going to move it a little bit. It's going to maintain 5 volts at the output for a little bit. But now, about 0.6 volts lower at the trim pot. Then you can see that the voltage started dropping right there. And it's going to move along with the voltage that I set at the trim pot. Spin it right there, it's going to change. And of course, since it's a PNP bipolar junction transistor emitter follower, it cannot get all the way down to ground, the output right there, because we got the base to emitter drop. So yeah, the voltage is following the base voltage, but it's about 0.6 volts higher. That's why we have about 0.6 volts away from the negative supply. Of course, it can't go higher than the full supply voltage of 5 volts. So it's going to level off at 5 volts. So now, here's my schematic diagram for the PNP bipolar junction transistor emitter follower. You see we got the emitter there, PNP because the arrow's pointing in. I'm using the 2N3906. But yeah, the resistor's on the positive supply right there. So our voltage out, the voltage here, and that's not to provide power, it's just the signal voltage, is whatever we set with the trim pot plus 0.6 volts. So if we go all the way down to 0 volts right here, because of that emitter to base drop, we will have 0.6 volts higher right there. Again, the little power we can get comes through that 1K resistor. We go up to 2.4 volts. This is going to be 0.6 volts higher. So 3 volts. Again, power provided by there. The transistor just conducts as needed to maintain whatever voltage we set here. Of course, we can go up to 5 volts. We can't get higher than the supply voltage. So we'll level off once we hit 5 volts right there.